Scott Patterson, Director of Marketing here at B Incorporated, home of the BeOS. We're here in our headquarters in Menlo Park, California, just north of the Stanford campus. We're glad you could spend some time with us today. We'll spend most of today taking a look at the B operating system itself and the technologies within it that make it so great at handling the real-time manipulation of high-bandwidth digital media on low-cost personal computers. Before we jump into the OS itself, there's a couple of people we'd like you to meet, so why don't you follow me?
Hello, good afternoon and welcome. Let me try and explain what we are trying to accomplish with the BeOS. First, we set out to start from a blank slate. This frees us from all the layers and layers of bug fixes and improvements that you see as sediments on older operating system platforms and make them slower, harder to debug, and really make it difficult to make the best of new audio and video technology, which is what we are concentrating on. With the BeOS, we are trying to create the ideal platform for the development of the new breed of new digital media applications. You've seen the success of Linux, so if you want a soundbite to summarize what we are trying to accomplish, we are trying to become the Linux of audio and video applications. So now, I hope you'll enjoy the demo, and the next person to explain what we are doing will be Frank Bozeman, our Vice President of Developer Relations.
You're about to see a demonstration of the BeOS, the operating system we've built from the ground up to be the best in the world for people working with today's rich media, audio, video, and images. If you're considering developing software for the BeOS, then what I hope you see is the opportunity to build groundbreaking applications for a platform where the playing field is truly level. I also hope you see a focused market of customers seeking software that goes well beyond the functionality possible with today's operating systems. If the demonstration you're about to see piques your interest, then please do check out our website to learn more about the variety of programs we have in place to help you develop your products and bring them to market. So, when you're ready to edit media far more efficiently than you may have thought possible, or when you're ready to do some development on a system that makes programming fun again, then come spend a few hours with the BeOS. Of course, if one day you decide not to go back again, we won't complain. Thanks for your time, and enjoy the demonstration.
We're ready to take a look at the BeOS. But before we jump right in, I'd like to tell you a little bit about the computer so you can gauge the performance that you see. This computer has 64 megabytes of RAM, a 3 gigabyte hard drive, and 2 Hauppauge video capture cards. These are about $70 cards that you can purchase at your local computer store, and we're using them to capture uncompressed video to play with inside of the operating system. Everything you see on the screen will be done in software. There's no additional accelerated hardware. The only unique thing about this computer is the processor, rather the number of processors. We're utilizing a dual Pentium 2 system running at 266 megahertz. Although we'll utilize both processors for most of the demo, at times we'll turn one off so you can gauge how the system runs on a uniprocessor machine. Okay, let's get started. We haven't made any radical user interface changes in the BeOS. The idea was to make the learning curve of the BeOS as gentle as possible. So there's a familiar concept of disks, folders, which you double-click on, and files and folders inside of those. Everything inside of the BeOS is live, so as I manipulate this window, you have live updating, even as I open and close the size of the window. There's context-sensitive menus, so if I wanted to move this item somewhere else on the disk, I simply navigate down the hierarchical file system and place it where I want it. This utility up in the corner is called the desk bar. It does a number of things. The first and most obvious is it keeps a list of your currently active applications. If I run the clock application, you'll see it's listed in the desk bar. I can customize the look and feel of the desk bar, placing it on almost any fringe of the screen. I can compress it, place it along the top of the screen, in any corner along the bottom, and I'll leave it up here in this corner, which is where I'm used to using it. One thing we strive for in the BeOS is a very responsive user interface. The way I'll demonstrate this is by bringing up a number of items on the screen at the same time. First, I'll launch a sound. This is a 16-bit stereo audio file being played at 44.1 kilohertz off the hard drive. Even though we're playing this audio file, I can move windows around the screen, access menus, launch applications. I'll launch our CPU monitor, as well as our Mandelbrot. I can iterate in real time down on the Mandelbrot, and even bring up a movie. The first thing you'll notice as I move this movie around the screen is that nothing stops processing. The movie continues to play all of its frames. The audio continues to play without any glitches. You can have up to 9 virtual workspaces inside the BeOS. I'll bring up the Workspaces Preference panel. And the best way for me to really demonstrate this is also to bring up the Screen Preferences panel. Here I'm working in a workspace in thousands of colors, and if I switch to Workspace 2 and then drag the Screen Preferences panel across, you'll notice this workspace is in 256 colors. And if I go to the third workspace and drag across again, we're working in millions of colors. This is a great way to organize how you work with your applications, perhaps productivity in one window, video editing in another. It's also a great way to preview graphics in different color depths. I'll bring up a graphic, and you can see what it looks like in millions of colors. And if I simply switch to the 256 color workspace and drag that graphic across, you can see what it looks like on an 8-bit machine across the internet. The BeOS is a fully symmetric multiprocessing operating system. That means that the entire OS, from kernel to applications, can take advantage of more than one processor in a system. In fact, the BeOS has been run on systems with up to 8 processors. This means as you go from 1 to 2 processors, you get a nearly 100% increase in performance. This application that I'll show you, Cinema 4D, takes advantage of the symmetric multiprocessing in the BeOS. I'll load up an image. And I'll also load up our CPU monitor so you can see the level of activity on each of the CPUs. The more green you see on each bar, the more that particular processor is being utilized. I'll go ahead and select Render. The threads in this application are set to have a priority such that they soak up whatever excess CPU is available, and that's why you see both processors go to work on the problem. Let me turn off a processor for a minute and go ahead and re-render this image. What you'll notice as I turn the processor on and off is the rendering speeds up and slows down. The BeOS dynamically handles allocating threads to whatever the next available processor is. Today your thread might run on processor 1, and tomorrow it'll run on processor 4. The BeOS implements protected memory. Applications and even the operating system processes themselves all run in their own protected memory address space. This means no single misbehaving application can take down the operating system or any other application. We've intentionally crashed an application inside the B operating system. What you see on screen is the resulting error message. Although this application is crashed, we can still run other applications. I'll go ahead and launch a movie and the clock application. We can return to our error message and get details about the crash, exactly what happened and where, and even go into the debugger. At this point, we could do things like seeing the state of the memory at the time of the crash. As soon as you exit the debugger, the BeOS cleans up and you can launch that application again. All of the networking in the BeOS is based on the Internet standard TCP/IP protocol. I'll bring up the Network Preferences panel for a moment. We'll take a little look. We have support for multiple IP addresses, multiple Ethernet cards. There's dial-in support through PPP. Our modem support is quite extensive. We also have a built-in FTP server for file transfers and a built-in telnet server. You can actually log in remotely to the BeOS and launch applications from the command line. You can make any changes to the networking on the fly without having to restart the operating system itself. We have a built-in web server and web browser. Our web browser is mostly here because all of the documentation in the BeOS is written in HTML, and we thought it'd be nice if you could read it right from startup. We refer to the BeOS as the MediaOS. That's because it's been designed from the ground up to handle the real-time manipulation of high-bandwidth digital media, such as graphics, audio, and video. Let's take a look at graphics. I'll bring up this 3D book. And what you can see is I can manipulate the pages in real time with good performance, turning them back and forth, whipping and warping them corresponding to how hard or how soft I pull the mouse. A gray book is pretty boring, so let's dress it up a little bit. I'll put this image here and this image down here. Now when I grab the pages, you'll notice that the image stays nicely mapped to the available surface of the page, no matter how hard or how soft I pull the mouse. We're not limited to static images. I can grab a couple of movies here, place one here and one here, and again grab the page and turn it back and forth. What you'll notice is the movie continues to play while it's being mapped to the available surface of the page. Things don't stop processing just because I'm utilizing this one object. Real-time audio control is another area where the BeOS excels. This application is essentially a 3D graphical representation of a soundboard. I have 16 separate stereo CD quality audio tracks being read off of the hard drive all at the same time. I can manipulate any one of them individually. For example, I can take this audio track, give it a lot of reverb, perhaps mute out all of the other tracks,
I saw my future enlarged, and then
and in real time, as the data streams off of the disk and through the OS, I can move this track to the left channel, over to the right channel, fade it into the background, fade it into the foreground. I can bring all the instruments back into play and fade the entire song into the background, and then bring it back to the foreground. The BeOS also handles the viewing and real-time manipulation of video. You can simply watch TV on your PC. We preserve nice motion on the screen even as you move this video window around. You can resize the window, and in this case, we don't lose a single frame. I can even have windows fall in front of a video window, and we do intelligent clipping. You can use your PC as a VCR. We've got our source material coming in. I'll go to the transport screen and begin hitting record. We're now recording uncompressed video right to the hard drive. I'll get a few seconds of material, hit stop, and play. We continue to play our original source, but we're also now playing the uncompressed video we recorded to the hard drive back in this window. Having two video windows, one over the other, is a snap for the BeOS. Let's take it a step further and apply real-time video effects all in software. I'll bring up my second source. So I've got two source windows and a compositing window. I'll make that window much bigger so you can see the effects that I'm going to apply. So here in real time, all in software, I can come in and do something like a vertical wipe, a horizontal slide from one source to the other, something a little more complex like a sparkle effect from one source to the other, or checkers. We can add a nice dissolve where we actually have transparency on both sources in the same window at the same time. and even do a page flip. And the thing to notice here is, as I do that page flip, when the very end of the page starts to curl, we actually reverse the image and play it on the back side of the page flip. Although we've seen some great performance so far, we haven't really stressed the B operating system out just yet. Let's throw a bunch of applications at it and see just how far we can go. I'll start by launching these 5 applications. Let's place our CPU monitor right here up at the top of the screen so you can always see the level of activity on the CPUs. Fonts inside of the BeOS are all scalable in real time, up and down. In fact, I can do this as I cycle through the installed fonts. I can apply any level of shearing back and forth, and even rotate in 360 degrees. Let's make that a little smaller and move it out of the way. We've got our Minesweeper down here, and also our web browser, which I'll send off to the B homepage. We'll make our Mandelbrot a little smaller and iterate down on that and place it over here. Let's bring up some TV as well. I'll make that a little bit smaller and place it down here. We'll bring up a couple movies as well. I'll place this one here in the corner and this one just above it. Let's also bring up a game. And as that comes up, you'll notice on our CPU monitor that we're at just about 100% utilization. The BeOS has a nice long degradation curve, so I can go out even past 100%. Let's bring up some 3D graphics. I'm going to use this pulsing image for this part. I'll make it a little bit smaller and map an image on top of it. So even though we're out past 100%, I'll turn off one of the processors, effectively halving the performance of this machine. And what you'll notice is applications don't come to a screeching halt. Our video source continues to play at full 30 frames a second. Our movies are continuing to play smoothly. You'll notice that the pulse animation is starting to get a little bit staggered, but that's because we do intelligent prioritization of threads. As soon as I turn this processor back on, you'll notice that the pulse animation speeds up again. I'll turn the processor back off and back on again. The most important thing to note here is that even though we're having the performance of the machine, we still have a stable operating system. Well, that's the end of our demo and our day here at B. If you take away anything, we hope it's this. The BeOS is designed from the ground up to handle the real-time manipulation of high-bandwidth digital media on low-cost personal computers. If you'd ever like to stop by for a personal visit, we give live public demonstrations of the BeOS every Friday afternoon. Just sign up through our website. Thanks a lot.
Dual Pentium 2 system running at 300 megahertz and 512 megabytes of RAM. Has a Yamaha ISA sound chip and an ATI Rage Pro Turbo graphics card, which isn't really offering much graphics acceleration at this point. As you can see, sound follows the focus of your program.